Alright, testing out new screen recording now, and hopefully this one will be able to catch my paint, my whole screen, because I realized while setting up for this that it actually wasn't recording my paint, which means that none of my other videos have my working out on it, which isn't ideal, but hopefully I talked them through well enough that they still made enough sense. But I'm gonna try container with most water, and I already was just investigating what the problem needs. So we have uh, an input list of various heights. We need to find the two that maximize the area with the x-axis, which would be 8 and 7. Then what we need to do is take the minimum of our two highest, and then which is 7 in our case, and then multiply it by the distance in the two indexes of the array, so 8 and 1. Alright, I'm going to pull up Paint and see if I can figure out what actually I need to do here to find the maximum area, because I don't want to just brute force everything. That's not a good way to do stuff typically. So I might grab this and throw it here. Where is my paintbrush? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. So this is our list as well. Alright, so we have our list, and what we need to do is find the maximum. So immediately I'm thinking some sort of we investigate the first and the second, which would give us 1 times 1, because we're taking the minimum and then these two. So we'd store that in our result variable. We'd then check. This even almost looks like some type of pruning like thing. It could be like, because we'd have to check 1 and 6, and then also 8 and 6. So 1 and 6 would be 0, 1, 2, 2. Times 1 equals 2. And then 8 and 6 would be 2 minus 1 is 1. But then we'd get to multiply it by 6, which would equal 6. And then we could update left pointer to be here. And we've got our right pointer here. Move our right pointer here. This is almost kind of like some strange bubble sort, where we're like bubbling the pointers to where they need to be. So we got left pointer here, right pointer here. We do 8 and 2. 2 being index 3. 8 being index 1. 3 minus 1 is 2. Times the minimum. 6. No. 2 times 2. 4. And then we have 2 minus 6, which is 1 times 2, which is 2. So now I'm guessing that because 8, 6 is our biggest so far, now we'll move our left pointer. I mean our right pointer, because it's less than. And if it's greater than, I don't know, I guess we move the left pointer, maybe? Yeah, that would make sense. So if it's greater than, if our answer is greater than res, we move left. If it's less than, we move right. I'm gonna say greater than or equal to, we move, no. If it's less than or equal to, I'm gonna say we move the right. We get to 5. Is that right? 1 and 6 times 1. 1 times 6. Yeah, so if it's bigger, the left one. If it's less than or equal to, we move the right. Alright, let's just keep working this out. 5 is number 4, 0, 1, 2, 3, 4. Minus 8. How was I doing it with the 6 before? Hang on. Let's start this again, make sure I've got it right. Because we could be starting at the left and the right, not just the... I reckon this could be a better plan. Because then we're maximizing our x-axis. I'm going to try that. So we start at 8 minus 0 times 1, which equals 8. So we got our area of 8. Now, what do we move in first? I reckon whatever the smaller value is, 1 less than min of 1 and 7 is 8. 1 is less than 7, so left. So then we move our left pointer here, number 8. Then we go 8 minus 1 times min 7, 8 equals 49. Alright. Yep. And then we see 7 is less than 8. So then we would move it to the next biggest. So we can skip number 7. And go to 6 minus 1. It's 5 times min of each, which is just 8, which equals 40. And now because we're moving our x-axis in, and we've already reached the maximum in the list, we can terminate here and return 49 as our best result. Alright, this could be difficult to put into code now, because I reckon there's going to be a few conditions here, like jumping indexes that we know can't work. Let's see if this is working now, because this wasn't working before, which was... Okay, that's good, it's working. So I'm going to start by initializing 2 pointers. So I want pointer left to be equal to 0 and pointer right to be equal to the len of height. So we need to loop over this list a maximum of n times, where n is the length. So for I, we'll just n equals len of height for I in range n. Maybe a while false so that we can return. N. If height or false. So we need our results list actually. First thing we do is height. We do index right. So xdiff equals right minus left. Then we do ydiff equals min of height left, height right. Do if height left less than height right, left equals added by 1, else right minuses 1. Here we actually need to calculate it. Xdiff times ydiff results dot append. We also need the max value in the height. Let's just check if this is all working so far. Oh, this is going to enter an infinite loop. That's not ideal. Okay. If the length of results... No, we don't need to worry about this right now. Results that append xdiff ydiff. So in total there can be see. In total there can be 1 comparison, 2 comparisons, 3 comparisons, 4 comparisons, 5 comparisons, 6 comparisons, 7 comparisons, 8 comparisons. Alright. If length of results equals n, I don't think this will be a great answer, but I think this should work. List index out of range. What? How? What list? How is it out of range? Left is equal to 0. Right is equal to the length of height. Right is only ever going down by 1. Left is only ever going up by 1. Height left is... If left is greater than or equal to right, return max results. Oops. I don't understand. So it's doing 8 times 7. Wait, I don't understand why I have to minus 1. Why is the length of N increasing? Um, eight. I understand this here. I get this part. I don't understand why I have to minus one from the index. So I am going to drop this into Gemini and ask what is going on here, because I don't get it. Alright, obviously. Yeah, okay. Oh, that's silly. Oh, that's silly on my part. Um, it was, yeah, I see. I get it. Um, well, cool. Hopefully the new recording worked better and my paint actually worked here for once. But yeah, awesome.